Okay, good afternoon, everyone. Today's class is about some kind of experimental working with some codes that we do some processing for natural language processing or NLP. And first time please go to this blog, upload LSA super code and basically NLP basic super code. Upload it to on your database account and also run clusters. Like this is 5 minutes to do all of them. So you need to create a cluster and upload those to cluster notebooks on your database account. Yes, I don't have time for the guys, so I think. So, but yeah, I mean, you can upload next time. Why not? Next week. So you can also upload sample pictures and but you don't have time for it. So here, let's compare Amazon with cluster because okay, so if you can't have cluster in a few minutes, no worries. I'll put the recording later and run the experiment. If it doesn't run in 15 minutes, sometimes it can take hours. So from here in the class, because we are very optimistic class today, and we were doing how many of these graduates next semester for this semester? Oh, from over Zoom to anyone graduating this semester? I think this is graduation, but it's doing something for Zoom. Yeah, I mean, so I have a news for you. So we have a experimental course in summer. So it is about introduction. So students have to make their introduction and how to make their own people and also introduce some different situations. So this is experimental. It's just steps from various steps and what is different points. And give you some points and you will be able to demonstrate them. So at the end of the semester, this is like 50,000. So even more technical than this course, if your discussion, let's say that 2 times more technical than this course. But even if you're not having the technical part, maybe by the half of the semester, you learn how to even stage this differently, how to stage this differently. So you know, every investment that we're talking about is for just significant investment because in long term there's a competition. But anyway, if I want to invest in my income, I make a point that my company is constant stage. If you want to that's my point. So the purpose of this course in the summer is you guys to be able I think yesterday is looking for people to because I think they make some back mean, at the end of the day, you just even create your own coin and just your question. So since you are a very good student, so if you graduate, if you are in a school, just take care of the course of your graduate, you can just email me later and it will be free for you. But I cannot guarantee you for the current student. So if you haven't graduated, I think school doesn't let you keep offering us, but I think same yeah. But I mean, as I say, it must be very technical because you know, because the point of the course not to be trader. You have to understand the background of the technology. So later, even if you don't get your own coin, if you know the technical part, later when you start to put some coin, you understand what you're talking about. So what is the point to different technology? So next summer, I offered that the experiment. Oh, they cannot hear. Oh, people always cannot hear me for some reason. So over Zoom, could you hear?
Not yet, Professor. We cannot hear your voice correctly.
Okay, cannot. So when the users can hear me, say something to them.
So can you hear me now?
Yes, it's okay right now.
No,
Okay, okay.
Yeah, thank you.
So I just said in the summer we have an experimental course. If you are a student, you can take it as one of your courses. If you're graduated, just text me or like email me, so you can attend for free. So in that course, which is very technical, you learn how to make your own blockchain and like make your own coin. So, but just keep in mind, let's say if this course is a kind of technical course you have, it's like at least 2 times more technical than this course. And I applied for a grant, so if they accept it, we would have a like blockchain and cryptocurrency lab at the School of Management. Okay, so by now I just ask all of you to go to Moodle if you couldn't hear me. So upload NLP Basic Jupyter Notebook and LSA Jupyter Notebook. Okay, so and also run a cluster, so you will be able to basically run the codes. Okay, so today we have some hands-on experiences on mostly data preparation part of NLP. As you might remember, I said the biggest part in NLP or natural language processing or text mining in general is being able to convert your text document to a numerical equivalent. But what would, if you convert to a table, what would be your column? What would you have in your text column? Or sorry, the tables of a text, and you might have some columns.
The person with it from the medium of the text.
Yeah, some of them, if it's Twitter, could be like medium, time, region, those kind of things. But I'm talking about specifically on text. The term or words. Yeah, so your words are your variables. So how many words do you think you have in the dictionary?
A lot. Yeah. I mean, that definitely depends on dictionary by dictionary and who you're asking. But
Yeah, I mean,
at least
tens of millions. So doesn't like, therefore, let's say you want to do text analytics. So each row. So do you have a number now?
According to the Oxford Dictionary, 171,000.
So 107. Okay, 175K. Let's say. So for each row is a text, could be a tweet, could be even a story or a paragraph. So, but how many columns you have? Potentially a 170K column. So it's hilarious. So how could you do like apply any machine learning algorithm? So if you might forget in the last slide, let's say one column could be start from Apple, hi, go. These could be your column, and under them you have 0, 1, 0, 1. If there is a 1, means that word exists in a certain like tweet, story, paragraph, so any of your body. So what would first of all, even if you have the best computer in the world, so 175K columns is hilarious. Even if you can process it, you might just stay in you might do overfitting. Or sometimes you cannot even train that. Your accuracy might be very low. So we learned some techniques to avoid this. So basically maybe for some of them, like if you see there, doesn't have any sentiment meaning, maybe you drop them. Or stop words, you drop them. Or maybe you end up finding a way that you summarize those columns. Maybe instead of 170K, maybe 500 or 1,000 words is enough for you. So we learn how to reach some meaningful number of columns that we can do process. Okay, so having said that, from PySpark SQL, we import the Spark session. We just assign an app name for that. So again, if you forget those, what does app name means? If like, again, you don't see in the Databricks, but sometimes you work with some server, high computing servers, and you run different jobs. Some of them might take like 1 day, 2 days, or like 10 hours. So when you want to check the progress of your work, you check by their app name. So it's the reason we assign an app name, but in Databricks, we just assign one job at a time. So maybe we don't use it, but just put the code here, which is, again, display like is not necessary, but later in the industry-wide jobs, you might see there are several app names referred to different jobs that you submitted. Okay, let's start from scratch. The first part is tokenization. So what does it mean? You get your body of words. It could, again, tweets, paragraph, text, anything. So then you split on different terms. we have two general types of splits, but again, if you Google it, you can find even more than that. But usually the basic and default one is just a tokenization function. And the second types are regex tokenization. So regex stands for regular expression. So if you forget about that, just search for regular expression in Python. So basically, the default or simplest way is just looking at a space. Every time you see a space, it just splits your document. With regular expression, you can basically make a little more fancy and more precise on how you want to split your document. Let's see some codes for that. So I'm importing tokenization, tokenizer and regex tokenizer. Also import some functions. UDF is just for basic function that I can make by my own self. Also integer type. So now I make my own data frame. So in my data frame has 3 sentences. ID of 0 to 1, 2, and also, as you see, the first sentence in this session we review basics of NLP. What's the first step? A question mark. We should first convert textual data to environment equivalent numerics. There are 2 major types of NLP: lexicon-based approach and predictive approach. Okay, so here you can see my data frame. So just ID and the sentence. So I do 2 types of tokenization. One just simple tokenizer, and I'm just saying that take the sentence column and make a new column of words. In that words column, just split the document. With the regex tokenizer, I'm just saying that the pattern is W. It just means you just split when you see basically alphanumeric characters and underscores. So let's first look at the simple tokenizer with the display method. I can see it. So as you see with simple tokenizer, exclamation mark is just a splitter. Also question in the second sentence, question mark is a stick to the step. So they may not that much meaningful with regular expression, since I just take care of alphanumeric and underlines, those would be dropped. Look at the second one. So in the second one, I use a regex tokenizer on the same data. As you see, now I don't have question mark. I don't have exclamation mark. So it just focuses on alphanumerics. Oh, I just forget that. So I told you UDF is for defining my own function. I can use UDF to create my function. I made a lambda function. If you forget lambda function, it's just a short function that you can define. So please, if you forget, just go back and check your Python documents. So what I'm doing here for words, my input is words, and I'm basically with len function, I'm counting how many terms I do have on each cell. And the output is just an integer type. I give you 1 or 2 minutes if you want to put some comments on your codes, then I go to the next block. By the way, if I teach too fast, please let me know so I can pause and just, you can take notes. Yes?
Is there also a fact that you can do the same thing for other languages as well?
Yes, you can. I don't know other languages, but I've seen the, for example, for Star Wars, I'm pretty sure there's a Chinese and Indian, Hindu, Chinese. I'm pretty sure that I have seen so many packages for other languages. But just keep in mind, NLP in Python and Spark has slight differences. NLP in Python has more functions than Spark. Spark is just basically created to be efficient on very large data set. However, we don't work with the large data sets. So I think they keep updating. So maybe in the future, NLP of PySpark and NLP of Python would be exactly the same. But right now, there's slight differences.
What's the difference between comment A and complete outcome?
So
What's if the command A is one word and then command 2, what and then S to separate. So they're breaking up the
yes, very good. Yeah, for first one, tokenizer, it just simply split if whenever you see a space or exclamation mark. The second one, I just said focus on alphanumeric. So exclamation mark, question mark, apostrophe, those are just excluded. Okay, in the next block, I'm applying my own created function. So if you might remember up here, I used the UDF to create my own function and I name it count tokens. I just want to see how many tokens each tokenization method provides. So with the with column, so first of all, from with column, you can create a new column. I'm just saying that create a new column of tokens. How? By applying count token function on words. And also saying that do not truncate the output. So I want to see whole of the columns. So I applied that count tokens function on both of tokenized tables to see the differences. So if you look at that too, you certainly can see, for example, the first one, it counted 9 tokens for the first sentence, but second one, 8 tokens because exclamation mark is excluded in the second tokenization method. Also, second sentence in the first tokenization method had 13 tokens, in the second one, 14. second type of second method of data preparation, I think is very straightforward. We want to get rid of stop words, and I'm just want to get rid of English stop words. But if you are doing basically text processing on other languages, you should try to find basically the stop words package related to that dictionary to get rid of them. So I import stop words remover function from Spark ML features. Then make a basically empty object. I'm just saying that the input column is words, and you should, after removing, put everything in the washed column. And also now I'm applying both tokenized tables, and you can see the results. So there's a slight, actually, I don't see that much of differences. Yeah, for some text document may not be that much of differences, but certainly stop words is same for both of them. So like the output is exactly the same. Okay, I give you again 1 minute to comment, then I go to the Engrams. So is there anyone here invested in cryptocurrency? You? Not now, okay. So another topic is Engrams. I don't go that much in details, but I'm just trying to just tell you some general ideas what is behind Engrams. So when I talk about India and Asia, so in your brain, you find some association. Or when I talk about Messi and Barcelona, it could make some association with you or for you, or let's say Beijing and China. It's still it could make some association, or Washington DC and United States. So why during your life you have seen these two words too much together, and also later on you understood that there's other relationship. This is what, for example, Messi is a player who plays for Barcelona, but yeah, because of tax he should he had to leave, but he used to be. So, but intuitively, when two words are associated together, they happen together in so many documents. For example, you expect Beijing and China appears to a lot of documents together, or Messi and Barcelona, or India and Asia, something like that. So, having said that, but like computer is not as smart as us, cannot understand, okay, what does capital means, or what does being a soccer player of a certain football club means. So how they do, yeah, Katie also invested. So okay, how they do, basically they try to focus on combination of words, like 2 words together, 3 words together, 4 words together. So if your computer see, for example, when it's focused on 4 words, four words together, Barcelona and Messi appears together a lot, it finds these two are relevant. Or when it just see China and Beijing happens to so many four words document or 4 terms documents, it can find some association. So we do it through Engrams. So basically, it just focus on the combination of 4 words, 3 words, 2 words, and see how many times some certain words appears together. So it can find some association or some basically topic modeling. So it could understand there is a topic that your computer doesn't know, but because of that topic, maybe some words happens together a lot. So it's similar to clustering. So your computer doesn't know what makes some words, some observation together in some certain groups or clusters, but not exactly the same. But here also, that happens through some mathematical calculation, but here happens through some Engrams. So it just take out 4 words combination, 3 words combination, see if they happens together a lot. So it can find some associations. Again, this is an interesting topic. If you later on you get a job who needs so much of text mining duties, I recommend to go over details of Engrams and do more details. But here we don't go under hood of the document. I'm just saying that this is good for finding association of some words together. Okay, so this is an example. Over our body of text, we just have 3 sentences. We want to make Engrams of 2 and 3. So we focus on 2 words combination, 3 words combination, and we check which words might appear together. I said that I import Engrams, and over I create 2 empty objects of 2 grams, and so Engram of 2, Engram of 3 just means combination of 2 words, combination of 3 words. Then one time I apply Engram of 2 over my tokenized data frame, and I show you the results. And also I apply Engram of 3 over my simple document. So let's look at the Engram of 2. In this session B, review basic. So maybe 2 words is not that much meaningful. So we look at the combination of 2 words together, doesn't bring that much of thing. Let's look at Engrams of 3. In this session B, review, we review basic. So maybe review and basics has some associations. This is a very limited number of combinations, but again, you might see some tokens might happen together. So later, this is again pre-processing. So later we apply, we go to more hands-on experience, so Engrams makes more sense for you. But I'm just saying that we split the document to combination of 2 or 3 or 4 words, 5 words. So later on, we apply algorithm on those Engrams to see if we can find some association between words. Okay, so the next one is TF-IDF. So I think we had some example last time. So basically, on top of just simple 0, 1, and also frequency. So sometimes some words happens more than one time. For example, if go happens like next in one part happens 3 times, we put 3. So one way just simple 0, 1 or just frequency, but we have seen some examples that some words might be need more attention. So we have seen through TF-IDF we give some more weights to some certain terms because they sound more important. One example was, let's say you look at email communication in CDC, and probably the word of COVID happens a lot of times, so it doesn't bring that much of attention. It seems to be a common word in CDC. But in Clark, if you look at the people's tweets, maybe COVID shouldn't be that. At this time, could be, but we don't expect to be too much frequent. So if there is a word of the COVID in students' communication of Clark, it might be something that you need to pay more attention. Maybe there's some COVID somewhere, or it seems people have concern. But let's say if you look at people's tweets in Clark University and somebody tweets about a bomb or fire, so it needs a lot of attention. But if you look at the, there's some military universities in the US, so people in those universities may talk about bomb and fire a lot of times, so it's common word there. So on top of this method, there's also a method of hashing. So it just means you don't have to do hashing anyway, but basically just hashing just as a summary. So it's just one package that helps to exclude some extra terms that are not useful. You don't have to do hashing for TF-IDF. I just put it here. It's just a TF hashing, just helps you to exclude some words that are not that much contributing. Okay, so from, again, PySpark ML feature, I imported hashing TF, IDF, and tokenizer. Also, I'm saying that when you do hashing, just pick the 20 more relevant hash or like terms and just focus on it. But again, you don't have to do hashing for TF-IDF. I'm just saying that if you have, let's say, 100 feed terms or words, just pick the 20 that are makes more sense. That basically they might happen enough time, or basically could be more contributing. Okay, so with IDF, so I calculate inverse document frequency, and I applied the object of basically IDF over the hashed data, and with inverse DF model, which I created here, I find TF-IDF, term frequency, inverse document frequency. And let's see the result. So as you see here, now some of the documents got some weights. So instead of just 0, 1 of frequency, I assign, some of them has the weight of 0, but some of them has like the weight are actually standardized between 0 and 1. Okay, the last but not least pre-processing concept is count vectorizer. Let me read it from the definition that I put there. The purpose of count vectorizer and count vectorizer model is to help transfer a collection of text documents into token count vectors. If a prior dictionary is not available, it is possible to use count vectorizer to extract the vocabulary as estimator and generate count vectorizer model. For the document over vocabulary, the model generates sparse representation which can be transferred to algorithms such as LDA. Count vectorizer will pick the top vocab size phrases ordered by term frequency through the corpus during the fitting process. The optional parameter min_df often affects the fitting method by defining minimum number of documents. or fraction less than 1. In order to be included in the vocabulary, a word must be appearing. So basically just saying that is another way that you summarize a very huge matrix of tokens. It's just saying that please pick the tokens that at least have appeared 3 times and at least in one document. So having said that, basically I make my own dictionary, but the dictionary that I create for myself are the words that at least happen in one document and at least 3 times. So for example, Apple won't be in the my count vectorizer dictionary because Apple is not appear there. So min df and vocab size for Apple in those 3 documents, both of them are 0. So basically, there's no mathematics behind of it. It's just saying that instead of having a matrix with 175K features, focus on your current documents and just pick the tokens that has some appearance, some minimum appearances. Okay, I give you a couple of minutes to put comments and then open the basically next Jupyter notebook. There is so on top of the methods that I talk here about how to minimize or focus on the words that makes more sense, you already know feature selection. So you can use feature selection on top of it. Also, there's another method that I'm pretty sure you have learned. So before your friends just open it up. We have also something like PCA, but for text mining that helps you to minimize number of features that you want to train. Do you guys remember PCA in statistics or machine learning? Let me show the. Okay, very good. Yeah, since you know this one, I'll also explain this one in more details. But again, if your future work needs some text mining, please go like study under hood of Engrams more or some other method. But I think we call it singular value decomposition or SVD. So SVD is similar PCA, so I can go under hood. But for the rest, if your work is heavily related to text mining, I recommend just spend a good amount of time. And even you can take some certificates or anything for text mining. So have you had text mining before in your Python classes? In visualization, okay. Okay, so this is a new Jupyter notebook, latent semantic analysis. So again, the overarching goal is just convert your text to numerical equivalent. The rest pretty much similar to other data mining project that you had so far. So we go over some basics of NLP and also maybe you need to do some packaging installation too. So let me read the some terms that again it might be needed. I think I already talked about natural language processing. It refers to a family of techniques used to derive meaning from text. That document refers to some collection of words and represent the instance of rows of our data set. So next time I don't say sentence, I just say document, or I don't say tweet, I say document. A body, a collection of documents, and is our entire data set. So our data frame, instead of saying data frame, we say body, just means data frame or data set. Dictionary is the set of all words that appear in at least one document in our body. And in the count vectorizer before, you have seen how we make a dictionary for our text document. So I just showed it in the previous Jupyter Notebook. A topic is a collection of words that co-occur. So in basically, Engrams is highly related to topic. When you do make Engrams, like 2 grams, 3 grams, or more than that, so later on you use some other algorithm to just basically do something like clustering or finding the topic. So I think semantic makes more sense, but we are doing semantic analysis, but it's latent because it's hidden within your textual document. So we want to get those semantics by using machine learning algorithms and digging into the text data and just provide those documents. So a question, do you think latent semantic analysis is a supervised or unsupervised learning? Why? No, I'm just saying we didn't talk about latent semantic analysis, but we got details later on. But it seems there's a hidden semantic that is in your text document. So probably we don't talk about the dependent variable, but later, I think further on you can answer this question, but I think based on what I said so far, your answer was correct. So we have 2 major steps. First, make the matrix. So again, the matrix just means your document versus tokens. Second, reduce the dimension. So we don't want to have a like 175K columns. We want to have some meaningful number of columns. So look at these 3 sentences. The quick brown fox, the slow brown dog, the quick red fox, and the lazy yellow fox. So you see my dictionary on the row, sorry, on the columns. So my dictionary has 1, 2, 3, 4, 5, 6, 7, 8, 9 tokens. Again, you might say there is an extra token, you should get rid of it, but never mind. So I'm not saying this is an efficient matrix, but basically this is your matrix. So you converted 4 documents into numerical equivalents. So having said that, how many dimensions this body has? Number of columns, right? So yeah, this is, so So since you already had something about PCA, I think singular value decomposition makes more sense for you now. For your friends that forget, so let me explain in a very simple way. Assume I have X axis, Y, and Z. Let's say I have a very flat plate on X and Y, and it has these 4 points. So for showing the location of these 4 points, do I need X-axis? This is a plate on XY.
You don't need the Z.
Yeah, is extra. So just assume you might have something similar for text analysis. So you might have some words that are not contributing. You need to get rid of them. So let's make it a little more complex. So now,
Professor, we can't see the board.
because you are not in the class, you're supposed to be in the class.
Yeah, now we can see. Now we can see. Yeah, it's like.
Okay.
Yeah.
So if you can see now, so I just said, hopefully you can see it, but yeah, I just said, let's say we have a very flat table on X and Y. It has 4 points. For showing the coordinates of these 4 points, I don't need Z-axis. This is extra. I can't get rid of it. So it's similar to text analysis. You might have some words that are not contributing on the meaning of or sentiment of some sentences. To make it a little more complex, assume there is a table that just intersects X, Y, and Z. Here, here, and here. And it has 4 points. These 4 points are on just one plate, but all 4 has X and Y and Z, right? So what PCA tells you, just say, forget X, Y, and Z. Let's say this is, you have a axis of PC1 and PC2 here. You don't have any PC3 because all 4 are on just one plate.
So this becomes, so basically 3D to 2D.
3D to 2D. So now if I want to show the information of these 4 points, I just use PC1 and PC2. Because it's just in like a 2-dimension. I don't need the extra dimension. So singular value decomposition does it for us. So it just takes, so you might do basically you might do a very regular expression, you get rid of some, you might get rid of subwords, you might do hashing function, some other things. Again, at the end, you still have too many variables. One way is using SVD or singular value decomposition. Basically, we try to have those sentiments with less number of variables or less number of terms. What did we talk about? Okay, so here what I did. So first I created the body from 4 sentences. The quick brown fox, the slow brown dog, the quick red dog, and the lazy yellow fox. Then I'm using count vectorizer and applied on my body. Basically, what I do, I make a dictionary from all the terms that happens in that 4 documents. Again, maybe you would say maybe we can get rid of the term, but these are something that you can do certainly. But here we just want to focus on SVD. So we create our bag of words. So as you see, those 4 sentences now converted to 0 or 1. So then I'm importing truncated SVD. I'm just saying that I want to summarize those bag of words, which is my which also shows my dimensions, to just 2 components or 2 PCs here, principal components. So I create an object of SVD, then apply it over my bag of the words. And here I just print the type and also show it. So now I can show that 4 documents with just 2 columns. So hopefully when later on I train algorithm, I won't face any overfitting because I got rid of. But again, for actual project, you don't have like 10 variable or like 2 components. Maybe you have 2,000 terms as a column, and then don't do just 2 components, maybe 10 components or 20. You shouldn't do too much simplification or too much. You don't shouldn't be aggressive toward finding the principal components. Okay, let's look at the components that I had. So look at the number 2 and 3. It's very similar, right? Almost same. What was that? So maybe 2 or 3 is about dog. So when we did summarizing 2 components, they're exactly the same. So that's interesting.
Is it higher the value of the vector?
No, there's no association. So it's like here, if you say X and Y is or like higher or less, it just said when here the 2 components are exactly the same, but because we do oversimplification, so you see one mistake. So now I applied SVD on number 2 and 3, and the component was exactly the same. It shouldn't be that because so it just means don't make too few components. Let's say like 10, 15. Number 1 and 4 is about Fox. Not that much similar, but at least 2 of them are positive.
So that means from the above, when I see the words, there are 4 ones, and the rest of the 5 of them are 4 of them are zeros. So I think it's from there it's able to tell like, so that's why I think the number Y is the same. So
So
I see, yeah, so about 2 and 3, there's like 4 ones.
yeah, 0 ones. Yeah, you're saying that if 0 ones close to each other, so the associated component should
so it
be.
doesn't take the total; it just takes from the same rows and columns.
So basically, for example, one of them might take care of 3 columns, another one next 3, something like that. What times? Okay, I think we have still time. So let's see. I think let's stop by here. I think the next one gets a little complicated, but okay. So later on, I mean, let's talk in next class. So in the next class, we go over to byproducts of latent semantic analysis. So one is your dictionary, another one encoded matrix, and you see that you also can focus on each word and see what is the interpretation of them in new, basically, components that we just created. Any question about your assignments? I think I didn't give you that much of assignment. Assignments are coming, but so yeah.
I still don't understand that the numbers for the SVD part.
SVD part?
Yeah. What does it mean?
2 here, you mean?
Binary coding.
So which number you're talking about? Number of components, you mean?
No, so I understand that we did the 1 0 at the start, then we got this result at the bottom.
So you understood this part?
Yeah, I understand why we did that, but I don't understand. So what is the association of those results with the?
So what is the association of this result with this number? Basically, I mean, so it's using SVD algorithm to just, you know, let's say how many columns we have. We have 1, 2, 3, 4, 5. No, here. I think here we had 4, 9. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. So instead of using 9 columns to show the 0 ones, we just have 2 columns that represent all of those 9 together. Like here in the table, instead of using 3 components, we have 9. So here we convert 3 to 2. With that Weisberg function, truncated SVD, we convert 9 columns to 2 columns.
So that's over.
It's the reason for 2 sentences, we find exactly the same values. So if you want, for your assignment, your project, if you have text in your project, for sure don't do too much of simplification. So if you make 2, you might see such a thing. For 2 sentences, we got exactly the same values, because it's just too much oversimplified.
So, but the numbers don't mean anything except for that it has the same number as other columns that they have. They are almost the same.
So if they get some similar values like here, we could say based on the component, number of components, they are same, but maybe actually they are different.
But they look different, and then it's
Yeah, because I try to have a better, you know, instead of using 9 columns or 9 variables, I try to focus on less number of variables. But as you see, something is very subjective. So number of components, when you want to simplify it, is subjective. Sometimes you, let's say in the real case scenario, maybe you pick 10 components, still you don't have a good result. So there's no mathematical way saying that how many components make sense or is better. What's your question?
no, so just because it was two, so that's the reason they would get like the same result.
They got exact same result.
Because you're- that's the same result because oversimplified with only
Yes.
if you choose more than 2, then the numbers would be better.
Yes, same as here. Okay, let me show you on the table. Sorry, on the board. So I'm happy you asked questions. These are really good questions. So let's say I have 4 points on X and Y. So none of these 4 points has Z value. So here, if I simplify my points, say my dimension to 2 dimension, my result is correct, right? I don't have any mistake, because each point has x, y, and z. Let me just put the value. So for first one, let's say x is 1, y is 1, z is 0. Second one, x is 1, y is, let's say, 4, z is 0. This one, x is 4, y is 1, z is 0. This one, x and y both are 4, and z is 0. And 0 is very bad. So it makes sense to get rid of z. There is no z. And it doesn't affect the accuracy of your result because you don't need it. So I can simplify my dimension by just getting rid of the last component. So what if I also, this time I want to oversimplify, I even get rid of y. I just want to have one component. Look at the first and second. These two just have one component that is exactly the same, but doesn't mean they are same. Because I oversimplify, I just have x to compare. Now I think these two are same. Or I think these two are same. It shouldn't be same. But since instead of focusing on two components, I said, no, let's just summarize, simplify with one component. Now this number 1, 2, 3, 4. So my point 3 and 4 has exact same value in terms of the simplified component, but doesn't mean that they are same. Same happened here. So instead of, maybe I should have 4 or 5 components. Let's just increase it. See if, there is no guarantee that I make a good result, but let's just do it 4, see if what happens with 4. Oh, I should create bag of words here. Okay, let's check number 2 and 3. It's still the same, yeah. No, let's say for some, even with 4, they are same. Let's just make 5.
Can we control decimals, the numbers? Like, can we control?
It doesn't go more than 4, huh?
Can we control the numbers like how many?
You should apply a round function topography if you want, not here. Or maybe they updated package. Let me check the documentation. Sometimes if they in the newer version you can put the number of decimals, that's better. But yeah, let's say just 3. Maybe next time I find a better example, but here I want to change that. But I think you got the point, right? So if you do oversimplification, sometimes doesn't help.
So this concept is related to small component regression, right? So yeah, I guess that's why you need to like you need to make the regression fast long.
No worries, sometimes people forget. I think just check some. If you forget principal component analysis, just look some videos. If you see principal component analysis, SVD or singular value decomposition makes a lot more sense. Yeah. Okay, thank you very much for your good question. That's for today. And in the next week, we keep working on this notebook, and also I show you more hands-on experiences. Thank you very much. Take care.
Thank you.
Bye.